In this video, we're going to be having a look at getting started with the PolarFire SoC Icicle Kit, the world's first RISC-V-based SoC FPGA. The first thing to point out is the PolarFire SoC FPGA. This part on the Icicle Kit includes a 254K logic element fabric with all of the great features we introduced in our range of PolarFire FPGAs. Now with our SoC, you also have our microprocessor subsystem to supercharge your FPGA. The Icicle Kit has several memory sources for code storage and execution, such as the system controller SPI and 2 GB of LPDDR4. There is also an eMMC flash, which is muxed with the SD card slot, and both are available to the MSS for code and data storage. The board also features several options for communication, such as 2 gigabit Ethernet ports, 2 CAN connectors, and also has support for PCIe Gen 2 root port and endpoint through the PCI connector. Some additional interfaces include our MSS USB 2.0, 4 UART connections via micro USB, a microbus expansion header for clipboards, and a Raspberry Pi I/O header which can be used to connect Raspberry Pi hats. These expansion boards can be controlled using protocols such as I2C and SPI. 4 user push buttons are available which can be accessed through the fabric along with 4 user LEDs. The FPGA can be programmed using the embedded Flash Pro 6 programmer available through the micro USB port or using an external Flash Pro via the programming header. Finally, the board also features a PAC1934 current and voltage sensor for monitoring of DDR, FPGA, and MSS power consumption. All of these features make the Icicle Kit a great starting point for using PolarFire SoC, whether it's for bare metal applications, Linux, and RTL development. Now let's power up the kit and have a look at it booting Linux. Out of the box, there's a Linux image programmed into the eMMC. I'll open up the COM port for MSS UART 0 and MSS UART 1 using a terminal emulator. The baud rate is 115/200. There are 8 data bits, stop bits are 1, and parity is set to none. The UART COM ports can be found in the device manager. If I power on the board now, in my console, I can see the HSS, or Heart Software Services, starting up on UART 0, and my Linux console is going to output on MSS UART 1. The HSS has finished copying the Linux image to DDR, and now Linux itself is starting up. The boot is finished, and now I've reached a login prompt for my console. My username is root, and if I hit enter, I'm now logged into my system and I can run from the command line. So for example, I can change directory into root and view my folders. I can run an lscpu command and view my CPU architecture information. Thanks for watching this first look at the PolarFire SoC Icicle Development Kit. If you'd like to learn more about PolarFire SoC, the Icicle Kit, and our development tools, please visit microchip.com/PolarFire SoC for more information.